few things from yesterday's build and test so that now you have some new ideas for today's build. So like I told you yesterday, today we get to hear from a returning special guest who uses cranes and depends on them in order to get his job done. As you may remember, Mr. John has been working as a civil engineer for over a decade and is currently employed by Skanska, one of the top 10 largest construction companies in the world. On a daily basis, John manages a team of contractors, he designs building projects, and works hard with the team to make sure their projects get completed efficiently and on time. He brought two of his coworkers with him today, Edward and Shannon. So would you please help me give a warm Cougar welcome to our 2020 resident engineers, Mr. John, Mr. Edward, and Ms. Shannon.
Shannon and I worked together on the 6th Street Bridge project, which was really good last year. We were able to build bridges and share our experience, or my experience at least. And so this is the project that we're building just right down the street. We're in the process of building the deck on the bridge right now. Some of the false work and form work is up, and we're going to start casting concrete here in the next month for the deck section of the bridge. So how do we use cranes on our job? So we start planning all of our crane operations well in advance of actually going out and constructing our cranes. So we have to build our cranes on site too. These things are massive, hundreds of thousands of pounds. Like this particular machine weighs about 300,000 pounds, so it has to come in on several different truckloads, and we'll build these cranes on site. And we'll plan out all our work on our computer programs. So some of the big complicated lifts that we do, we try to plan everything out logistically, so where the crane's going to set and how much we got to pick up and how heavy it's going to be, make sure that everybody involved is real safe and that we don't break things along the way. So we take pay particular attention to safety and all the details before we get started. We try to think through everything and write everything down before we start building and lifting. And so these are some of the more complicated picks that we have, and Shannon is in charge of this operation where we're picking some massive rebar cages. The cage here is 200,000 pounds, so it fills I'd say it could fill like 3/4 of this room, and we need to use what's a lattice boom crane here to pick those and set them in place. Here's another little smaller pick, and a different type of crane is used here. This one's a hydraulic crane, and we're just picking up a little form work here. This one's about maybe 5,000 pounds in weight. So a little bit smaller load that we're lifting here, but we got some tricky stuff in this picture that we got to avoid. So there's some overhead power lines that we got to watch out for. We've got to pick up and lift up over the top of these objects that we're building that are in place that we don't want to hit. Here's another picture. This one is similar to the previous slide. So this one is where it's actually set in place. And for this operation, it was a little too heavy, a little too tricky to get in place with just one crane. So you can see in this picture, we actually have 3 cranes working at the same time, in tandem, all coordinated, and in order to set this piece of rebar in the right place. So I'm going to hand it over to Ed. He's going to talk about a little bit of his experience on our Purple Line Tunnel project and how he uses a little hand-powered crane.
All right, hi guys. So I work on the Westside Purple Line extension. Basically, we are building 3 underground stations, extending the Purple Line, the Metro Purple Line, which is running down Boucher. So just as Shannon and John are building above ground, I am actually building below ground. So we have 3 underground stations, La Brea, Fairfax, and La Cienega. And this is mostly a tunneling project and a systems project. So moving on. So since we're going underground, we have 3 underground stations, we need to excavate. So basically we need to dig down 80 feet from the surface level. So as you can see here, I'm on the surface level, and you can see all the way, that's about 80 feet down. And we have, on the left-hand side, we have a scaffolding system. It's for our workers to walk down, and as you can see, that's a lot of stairs for them to walk down and carry equipment that may take too long. And on the right-hand side, we have a emergency exit in case there's an emergency down below. They could just use the ladder to climb up. But I can't really see it, but our pulley system is on that, which I'll show you guys on the next slide. So now on the last slide, I showed you how we had the scaffolding system, and workers, instead of just carrying the equipment down, we have a pulley system right here on the left-hand side. So what we do is we take our heavy materials and equipment, we tie it, and we slowly pull it down using the pulley system. For this one, there's really no mechanical advantage due to being one fixed axle, which we'll explain in the later slides about how we can gain mechanical advantages adding more axles. So, next slide. All right, so this slide is all about the types of pulleys, what the crane uses. So the first one is a fixed pulley, which I showed you on the last slide. So we have one axle, and it's at a fixed point, and it's used to lift this object. So let's say this object weighs about 10 grams. You're gonna need to use the same amount of force right here to lift the object. So there's really no mechanical advantage except you're redirecting the force instead of having to lift it with your bare hands. So on the second one is a movable pulley. So this one you do have a mechanical advantage because you have it tied to a fixed point right there, and you have a movable axle. So you have all the load is on one side, and you're using your force to pull on the other side. The third one is a compound pulley. So it's a combination of the fixed and the movable. So you have the fixed on top, and then you have a movable on the bottom. So you have the object, and it's being lifted with the So you have the object, and you have two load bearing ropes right here, one right there, one right there. So let's say let's say the object is about 10 grams. So the force you're gonna use right there, showing the direction, it'll just take 5 grams of force to pull the object up. And then the block and tackle. John, you want to explain that one?
Yeah, sure. Yeah, block and tackle. So it's like really important. If you guys learn this, block and tackle, and then when you guys start driving cars and you go get your 4x4 stuck in the mud, and you've got a couple pulleys and a winch, you can get your car out almost with the hand power. If you so what's going to happen? I'll explain why. So you count 1, 2 lines right there, right? So those 2 lines are going to help you lift. They make you like twice as strong. If you start wrapping that line around these 2 pulleys 1, 2, 3, 4 times, it doesn't make you stronger, but it shares the weight that you're lifting by that many lines that go in between those 2 pulleys. And we use this all the time with our crane work. This is exactly how our cranes are built. So that fixed pulley on the top, that's the pulley that's fixed to the top of the crane, and the movable pulley on the bottom is the pulley fixed to the load, or the hook where you hook the load. And depending on, like I said, depending on how many lines you wrap around each one of those pulleys is the amount of force that you need to, it's a fraction of the amount of force you have to use. So keep the block and tackle in mind as you see some of the pictures of the cranes. You can see it here, the block and tackle up front. And Shannon's going to explain to you guys how the lattice boom crane works and some other cranes.
So after hearing everyone talk this morning, it makes me very nervous because you all talk very well. But on the crane, one of the main components that you consider is how much you have in a counterweight, because if you have force that you're lifting on one side, you're going to have to offset it on the other, otherwise you can have your crane overturned. So that is a big part, is the counterweight on the bottom. The cab is where the crane operator will sit, and that's where they control the crane, allowing everything to come down or lift up. And then we have the boom. You have to consider the length of your boom and the radius that they're sitting at. That will change the capacity of how much the crane can lift, because you do worry about the overturning and the strength of the crane. As John explained, we do have the hook, which acts as the movable pulley, and then you have the fixed pulley up top. So on here you can see that there's multiple parts of line. All the different lines that are coming down, that increases the capability of the line for lifting, because it reduces the load each one is sharing. Another thing to consider is that the more lines that you have, you also have to account for that and the weight of the load that you're lifting, because the lines do have a weight that are added to it. So those are some of the basics. Another type of crane that we have, this is actually a picture from a project that we are doing over in Corona. On the 15 project, they were using a gantry crane. So the gantry crane goes all the way across where you're lifting the load, and it lifts from underneath. So it's the same common principles, but you don't have a boom. Here you have your support frames and your girders, your hook, and your hoist trolley. But as you can see, there are those lines that go to the pulleys to help with the capacity of the load. And then your cab is sitting within the support frames. And over here, this is where the operators will control the crane operations. So this one is just a fun little concept. So moment is an equation of force and distance. So you have a certain amount of force that is a distance away from the center location. You have 10,000 newtons and then 3 meters. So then if you multiply the two together, you'd have 30,000 newton meters. Then on the other side, you would have the capacity up to that 30,000 newton meters. So if you have 6 meters away, then what times 6 meters would equal 30,000? Does anybody want to guess? 5?
5,000.
Yep, good job. Yes, so 5,000 newtons would be the capacity that you can lift on here. Looks like we have a question over there.
Have you ever built a crane and it fell?
I have not. No, luckily I have not. But I've been around operations where cranes have fallen. Seen lots of videos. I mean, you could go on YouTube, crane collapse, and see them all day long. It's not pleasant when it happens. It's very dangerous. And,
I have a question about, the cables for lifting. It's like, where do you put them, and how do you know it's strong enough to pull a 200,000-pound load?
Okay, yeah, that's a good question. So the line is wound around a drum that has a hoist motor on it. So that hoist motor has a certain amount of power. It can pick up and turn and pull a certain amount. Like if you were holding the line, you have a certain amount of force you can put on it. So then that line runs up over the tip of the boom, and goes through a pulley or a shiv and goes down into the hook, which has a block on it, which has other pulleys, or the line can run straight to the hook. And so that line also has a certain amount of strength in it that can pick up a certain amount of load. Usually it's something really close to the amount of load that that hoist motor can pull. So those are about equal. Now those are going to be about, a sixth or a fifth sometimes of what you want to pick up. So that's where the pulleys and the mechanical advantage comes into play. So if you've got a 200,000 pound load with a 10,000 pound line capacity, then you need to make sure that you put enough parts of line in between that top shiv, in between the pulleys, so that you distribute that 10,000 pounds between the 200,000 pounds that you want to pick. So you have, what's that, 20 parts of line in there, which is a little much, but...
So you would like wind it around the pulley system?
Yeah, if you just keep winding, so you gotta have one line free to pull the force. You gotta have the other end of the line attached to the fixed pulley or some other movable part, and then you wrap. As many times as you wrap, that load is going to seem lighter. So if you don't have a strong enough line, then it'll account for whatever you have the weakness in the line. Yeah, we typically do that all the time. Yeah.
We have time for 2 more questions. How about one from middle school, one from elementary? Yes, right here in the middle. How many projects have you done?
I've built 30 bridges, yeah, and worked a couple years designing a few others, like maybe 5 other bridge designs.
Jake.
You don't have enough counterweight on one side. If you have like too much counterweight on one side, it'll just go over.
Yeah, maybe try it. I mean, go back and see what happens. So if you have like some pivot point, right? Some pivot point, and you've got 2 equal arms, and you've got 2 equal weights, that's not going to move, right? You don't have to have the exact amount, but you need to balance it by the distance away from the point where it's going to overturn. So our slide that Shannon talked about was showing that you were picking up a load that was like twice, it was like 2 times further away from that pivot point than your counterweight was. So your counterweight had to weigh twice as much.
But how do you adjust the pivot?
Well, you can keep the pivot point where it is and adjust everything else. Or move. Yeah, you aren't able to adjust the pivot point. Like on the big cranes, there's a center pin inside the cab, and everything kind of rotates about that. And it's going to be fixed. So we adjust, what we do is we adjust either the counterweight or we adjust the angle of the boom so that you bring the load closer to that point of rotation or further away to balance out the load.
Thank you. That was a good explanation. I saw a lot of people testing out that idea of should I use counterweight or should I bring my boom closer to the base. I was seeing sometimes it was working when people were doing counterweights, and sometimes it was really working to make sure that this boom here was closer and it didn't lean out too far. Because a lot of times people's point of failure in their cranes were where the boom was just breaking, right? So maybe using some of the information that they shared today, you can go back and redesign it, either adding a counterweight into your crane or adjusting how far away your boom is